The block diagram of the feedback control system is shown in figure. The overall closed loop gain G of the system is, the block diagram is given here. If you use block diagram reduction, it will take a long time. That's why let us assume that this is as if it is a signal flow graph. Don't draw the signal flow graph because it will consume time. So here we have to note down the nodes. This is one node. This is another node. This is the third node. This is fourth node. Node 1, node 2, node 3, node 4, node 5, and origin, one more node. That's all. Now we can write the Mason's gain formula. That is y of s divided by x of s equal to, in the numerator, forward path gain. What is the forward path? The forward path is, this is the forward path. This is the forward path. Therefore, G1, G2. G1, G2 divided by 1 minus sum of products of individual loops. This is one loop. This is one loop. Negative is there. That's why minus G1, H1 minus another loop. This is this is the second loop. That is G1, G2, G1, G2. This unity gain. That's why that's all. Therefore, the answer is G1, G2 divided by 1 plus G1, H1 plus G1, G2. That's all. Therefore, B is the answer. So don't draw signal flow graph. What is signal flow graph? This is the signal flow graph. But in the examination, don't draw it. This is minus H1. This is G1. This is G2. X, Y. But don't draw the signal flow graph in the examination. Otherwise, it will consume time. That's why we have to visualize the signal flow graph mentally. That's all.